Welcome to a new test and teardown video. This time it's a LakeShore 330 Autotuning temperature controller. This one is specially made for cryo materials, so that means super cold stuff. And I think it works by opening a heater to the cryogenic materials, and then you can adjust your temperatures and all that kind of stuff. So I don't know if I'm able to use it for anything real smart. The special thing about this is auto tuning. So that means the PID parameters, you can of course dial it in manually if you want, but you can also enable the auto tune, and it will try and optimize the parameters all by itself, because PID setup is not that easy for people who don't know all the parameters. So I think it's pretty cool with a temperature controller with auto tuning. Maybe it is possible to program this for other temperatures and use the heater output and to warm up stuff as well. I don't know if it will allow me to do that. As far as I can tell you, let me show you the back. So we can control the heater output here. We got a high and a low. Maybe that is to channel A and channel B, or maybe we just have two different temperature sensors here. As far as I can see, I've been looking around the manual. You can use more or less all possible temperature sensors you can imagine, from the most simple, just a diode, to all the most fancy smancy sensors. Yeah, you can probably spend all your money on if you really want to. And then there is this of course goes via AD converters to the software, and then the software control the output here to your heaters. And we got some serial port interface, and then IEEE interface as well. Maybe I should try and see if we can open it and have a little look, right? Oh yeah, what I can show you a little clip. You can see how nice and beautiful it is right now, right? But it was so nasty and dirty and slimy when I got it. So I, of course, always clean stuff, so it looks like I always get really nice and beautiful stuff. But sometimes I take a little video or some pictures from when it was really nasty when it came in. Still cleaning. And it was so yellow, you can still see what happened here, see? Then you can rub this off using alcohol. So I think this is like a smoker's home or something like that made all this super duper dirty. So now we're inside. It was actually quite easy to open. Let me show you a little bit around what we got here. We got one big main board, and also a little bit untraditional design. So the main transformer is located all the way at the front panel. Look at that. So that's mains entry, filter, and the on-off switch is down there. It's not easy to see. And then there's a funny bent piece of metal that goes to the on-off switch with some really, really thin, flimsy wires. That the black and the white one there, that will be the on-off switch to everything. But of course this is not using a lot of power. It's only about 50 watts. I think that one is a NEC CPU, so that will be our main CPU. We got a little port driver, and those are of course the port driving to the display section and to the all the switches input here. That will probably be multiplexed, and so it's software multiplexing the different switches. that one is a little bit special. So it's a RAM with a battery backup on top of it. And this one was replaced in 1990. Is that a 98 or something? Let's have a look. Yeah, 98. And on top of the EPROM, the two EPROMs, I found those two stickers. They fell off when I cleaned it. It was so full of nasty dirt and stuff. So I had to go outside with a paintbrush and dig my way down so we can actually see the components. And yeah, down there, that one here, this TMS thingy, that one, that will be the IEEE chip. So the serial port, they're using an LT instead of a Maxim 232. So that's quite interesting. We've got a little voltage reference down here near the connectors, so it's mounted far away. We got some op amps, and those are some really funny switches. And it's probably for the different sensor types, temperature sensor, this and that. AD converters, DA converters. All this is, of course, optically isolated. So we got some optocouplers. I think we've got quite a few. All that is also optocouplers, I guess, right? And yeah, just some more op amps and stuff like that. I think that will be the heater outputs. So it's a linear output driver for the heaters. Why can't we just see what that is? Down there is just a power op amp or something like that. And the rest just normal linear regulators and all that kind of stuff. Yeah, it's the circuit board is covered, I don't know if you can see this, with some white slimy nastiness, and there is also a smell of something that blew up. And if I look at the backside of the circuit board, look at that nasty white color. That is really weird. Maybe I should try and take a little cotton bud here. No, it is totally damaged. So the circuit board is just permanently damaged somehow. Weird. That is puzzling why it is looking like that, see? And here they left some coating or some glue or something, and here it is nice and fine. So yeah, some nasty, maybe I should go and wash my fingers, because I don't know, it also feels like this is not good. Be careful. Yeah, this is not good at all. So let's just see what happens. Okay, here goes all or nothing. Mains is applied. I'm ready here. 23 watts. Okay, so we got some errors. Obviously, that's probably the sensors, right? So I didn't connect any sensors. What I can read in the manual is I should be able to input type, see? A, B. Is it responding to all the different? Yeah, you see? I mean, so far so good. All the... Oh well. I don't know. Well, let's try and let's try something. So let's try and play a little bit with the sensors. As you can see, this is DIN connector. It's a little bit special, the pin out here, right? But I just happen to have exactly what we need for the task on stock. Yay! So let's hope I did this right. I took a 4002 diode. And I think I will now try and see if I can figure out how to do the 4-point diode mode of temperature sensor. We go with the diodes mounted. And look at that. Now there's no error codes. Let's see if we can say input type. What is that? Oh, so you hold it and then you how's that working? Do I really need to read the damn manual? Ah, so that's the heater. How cool. Off. So high. And then it goes like that. Luckily, the different sensors and all that configurations, that is pretty well documented in the manual. So I've been through all those different setups as you see here, and it's done by those fancy looking dip switches inside the unit. But no matter what I do, I can't make it read anything that is just even remotely correctly. So unfortunately, there's definitely something really bad going on. I will try and investigate a little bit deeper. In my desperate attempt to get this up and running, I am of course looking on my thermal camera. And it's quite funny in the good old 90s. Look at that CPU down there, this little MOS device down there. See, it's running 50 Celsius. That's quite warm. We've got some normal logic ICs. They're also quite warm. And what else is warm here? Yeah, some analog stuff. Yeah, the IEEE IC is also running quite warm. I saw a power supply regulator down there. That is 90 Celsius. That can't be good. So this explains probably why all the analog stuff is not working. See, down here we got two regulators, a positive and a negative, right? And one is really, really warm and the other one looks normal, right? So yeah, that's probably why it's not working. Maybe I can figure that out. I will go and play a little bit around with a voltmeter and see if I can figure out the different rails on the op amps and stuff like that. Oh, that sucks. It is of course completely dead. When I measure around in all this area here, nothing. There's no data, no BBD, nothing goes in and out of all these things. And you see why? I pulled out the EPROM here, and there's absolutely no difference whatsoever. So all this stuff here is connected to that EPROM, all those data buses, and not a thing. So I mean, either it's erased and or whatever here is something really more deadly wrong with this unit. I don't have the schematics or anything, and frankly I don't really have anything I can use this cryogenic heater cooler regulator for anyway. It was just fun to play with and see if I could get it up and running. I'll be happy to show you that it's doing exactly the same thing without that EPROM. See? And you can still click the input output here. You can click the curves, address, ball rate, the heater, and all these things. And I mean, control, set point, escape. You go back, and you go, set point here. And you can dial up and down the set point, like that. Anyway, that was not so much fun. I was hoping to play with some sensors and some heaters and stuff like that, but this is just trash for now. Anyway, maybe I will play with this in another year, but right now it's gonna go on a little pause, I think. So thank you very much for watching. See you around. Bye bye.